Hey, everybody. Thanks for coming. We'll jump into it. We still have some folks trickling in. So I know this is officially the last session, right? So as you can see, this was not a late addition. This is totally planned. We're excited to kind of walk you guys through the demo that you saw yesterday in Satya's keynote. This was the Lowe's HoloLens demo. And then we have so much to unpack that we actually figured we could make it a whole session, and we want to have an interactive session, and if you guys have any questions, we'd love to take them. There's a couple microphones, so feel free to jump in at any time. My name is Nino Bice. I'm a product manager on the Cortana Intelligence team. The Cortana Intelligence team and the HoloLens team collaborated together to build this demo. So you can almost imagine, this is like a HoloLens retail demo backed by machine learning platform, sort of a way to think about the stack. And on stage with me today, most of you if you saw the demo, you should recognize Senya and Wei Hong. So Senya and Wei Hong are part of our engineering team, and they built this demo, so they'll unpack it for you. So before we jump in, I kind of wanted to set the stage here a little bit and talk about how we planned this demo. When we had the original idea for this, it really started as, HoloLens is working with Lowe's, and it's live today. It's actually holographically designing a kitchen is live in their lab in Washington today. And we sort of challenged ourselves, Cortana Intelligence and the HoloLens team, to work together to say, how could we really envision some next generation retail experiences, right? So we all put our thinking caps on, and we really had a couple goals. Number one was, of course, to demonstrate retail personalization isn't just 2D, right? So as we all know, we have Oculus coming, Samsung has a platform, we have HoloLens, there's combinations of augmented reality, which is HoloLens virtual reality. And one of the key things is you can think about as you and your business approaches this experience is the technology we've built to personalize retail for 2D can also be applied to these 3D experiences as well. So that's sort of a high-level goal. We want to demonstrate that. The second thing is really the transformational stuff. So let's do something really cool. So those would be things that we'll show you today how we built. But what we really realized when we kind of huddled was a lot of the experience that customers have in retail, and I know Jen kind of mentioned this yesterday in her demo, it really starts before you walk into a showroom floor. If you think about some of the biggest applications in our lives, they're Facebook or Pinterest or Etsy or Houzz, and this is just retail, right? And there's other ways you could apply personalization to those apps. But we wanted to figure out how to use deep learning and all the various ways that you can use that and apply that to extract that sort of ability to understand the customer deeply. Because we're all spending our time like curating the things we love, whether they're pictures or comments we're making or conversations we're having with a company, right? These are all sources that we wanted to consider. So we really spent a lot of time, and I urge you guys too, if you're interested in applying this to your business, think of all the ways that you can understand the ways that customers express themselves and what they're saying. Another thing too was a lot of these are creepy scenarios, candidly, right? So we wanted to make sure that we did this in a stylistic way, but also in a way that maintained customer trust and integrity. And we think we've also reached that as well, right? If for all of us in the room, most of us are fairly technical, OAuth 2 is a big thing. So there already is a design pattern around safely and securely sharing data with a third party. So we built in a lot of those principles as well. But this is really sort of how we thought about this demo, right? All the ways we can all the signal we can use to build personalization. So what you'll see today, and again, I know we all saw it yesterday, but and this will articulate sort of, I think, a little bit of the agenda here is we really had 3 core use cases.
Should I show the recommendation slides?
Somebody said no. The first use case was effectively how do we build this out-of-the-box personalized experience. So again, like I said, you've spent months, maybe years, sitting down, curating your life, people you love, places you've been. Are you guys switching my slides?
No, let me check.
Sorry.
Wait, hold on.
I think we lost the laptop. someone's doing something. So we've really spent a lot of this time curating. So we wanted to access that signal. So what we did here is we accessed, in this case, Pinterest. So this is obviously a retail design experience. We looked at a Pinterest board that the customer securely shared with the application through OAuth. And these guys will go into deeper detail. And we use that to give you out-of-the-box personalization. So you, imagine, as opposed to walking into an experience, this could be applied to a 2D website as well, and saying, hey, here's what I like. Here's the way my style has changed. We can actually just understand that within minutes and then build you that deep personalized experience. The second thing is giving a really contextual experience. So in this case, what we did is we understood all of the ways that customers had designed these combinations of kitchens. This is after we've already understood your preference. And we've understood all the ways that designers thought that palettes and style patterns would go together. We'll talk in detail around that. So we demonstrated that through a rich recommendation experience. And then the third thing, and this is where it got really, really, really fun, working with HoloLens, is that we now had a new UI paradigm with a bunch of new sensory signal. So, of course, in this case, you're wearing a massive headset, and you understand where you look and how long you're looking there. So we overlaid that with rich text analytics. So we were able to deliver an experience where customers could look and interact and experience with a product, and we were capturing that signal and turning that into really useful analytics for the enterprise or the product planners. So those are the three core experiences. You guys want to take it away?
Thank you. So just before we start, right, just to give you a sense of the events that led on to the creation of the demo that you saw yesterday, right? We received a call from Nino, and he said, hey, figure out how to connect HoloLens with Cortana Intelligence, and that's how it all started, right? Now, for those that have not seen the Ignite demo, Sanya, you'll be familiar with, who is on stage, right? It's going to walk you through some of the applications, and then we're going to start off with showing you what the applications are, right? Before we dive into the code underneath the hood, right? That shows how we connect things up, right? So Sanya, take it away.
Hi, I'm Senya. I'm on Weyoung's team on the engineering side, and I help building the Lowe's environment, like the collaboration with HoloLens, our DNN backend, and the team that does the actual image search. And the way we started is we needed a portal for the customers to submit their Pinterest images or go through a Bing search and develop or select a set of images to submit to our DNN backend. So we started by building a portal that had a little bit of authentication. And then it led into a portal that has Pinterest integration and also Bing image search integration. The users are prompted to import from their Pinterest boards the boards that are relevant. For example, a board with kitchen images pinned. They can import their pinned images into the portal, go through them, and then maybe add the pictures that they like to the gallery. And like every other live demo, it doesn't want to work when it's time to work. Or they can go on and then on the search box type the favorite subject or the subject of the kitchen that they want to research and make part of their kitchen. Like for example, a kitchen island. Get through pictures of islands, select the ones they like, populate their gallery with the images. For example, if their favorite is the white type of kitchen islands, if they want to add, they might add a fridge, cabinets, and so on. Maybe if the image is too big, just crop a part of the picture. Create their gallery, customizable gallery, and then submit it to our DNN backend. Before we submit the pictures to our DNN backend, we save the keyword search so that we can do a more refined search on the backend. And we also run our images through our cognitive APIs, which will return tags and a description of the image to check that the images are actually images of kitchens and images of objects that will return good results from the collection of data that we have in our backend. And this is a step that will be taken at home by the customers when they go and then set up their Lowe's appointment. Once they show up in the store to make their appointment, and we're using our own profiles for the appointment on our dev environment, They are prompted, the customer service representative matches the time of their appointment and their profile with their MyLaws account. They import the pictures that they submitted in their backend. They populate, they get their selection, they call our backend API, which Weyoung will go more in detail into. They get the images for the various categories and they try to match it with the Laws vignettes that are available as data set, or with like various images of like backsplashes or actual fridge, faucet, and other elements that were part of the data set submitted. And then from there starts the customization. Those elements are part of the scene that is built using HoloLens and are the ones that the customers can actually get started on swapping in and out together with the other selections. As the customer service representative is assisting the customers going through the selection with the HoloLens, we have another integration on this app, on the Laws hologram app. We have live connection to the recommendations API that are available through the Cortana Intelligence Suite. And as the customers go and they favorite particular items around the kitchens through the HoloLens, we can call our backend, and that gesture is triggered by the HoloLens. We call our backend, and for that model item, we retrieve the other items that people who have viewed also search for. And that's part of the experience, part of the in-store selections that they get. I'll hand it over to Weyoung to go more in detail about the DNN and the recommendations.
Sure. Thank you, Sanya.
How many folks in the room have implemented deep learning in any production scenario today? Okay. How many folks are interested in learning about it and sort of aspire to?
She's up.
Okay. Awesome. Great.
Is mine up?
So Weihong's got a really cool ways showing how many folks have heard of convolutional neural networks before? Okay, cool. All right, so that's actually implemented here. And then one more question. How many folks have heard about our CNTK toolkit, our computational network toolkit? Okay, great. Tried it out? Tried a project yet? Okay, awesome. Very cool. And then one more question while we're at it. I love this. How many folks in the room are in retail in general?
Yeah.
Okay. Manufacturing? Okay. All right, great, thanks.
This is 6. Do you have the slides backstage? Do you have the slides backstage with them?
Oh, they're right here.
Oh, they don't have it one. Do they have a copy backstage?
Yeah, I gave it to him.
Oh, we could run the slides backstage then.
It's cool. Yeah, they have it.
Maybe we should run the slides backstage.
He's looking right now.
Oh, okay. And then just give us the clicker. That should work.
Do I have time for maybe 30 more seconds? So
Yep.
I have one more question because I'm really nosy. How many folks use Pinterest? Okay, like Pinterest for Etsy or House, either one, those applications? Okay. Yeah, it was really interesting. We were going through the options of who to partner with, and I think per volume, Facebook is just by far and away the largest photo sharing
Maybe
service
just
or photo
open it.
storage service on the planet. Yes.
Unplug.
But
This solution will serve low cells or
Okay.
plug in other manufacturers' appliances?
that is the most beautiful question ever. So let's unpack that. Thank you. So we're going to cover this at the end, but I'd love to jump forward. And then real quick.
Yep, go ahead.
Okay, because I think we have time. One of the other reasons that we selfishly pick this is because this design pattern, we believe, applies to many industries and many verticals, right? So this is just a really fun way to show it. I mean, we all are very passionate about, most of us, about our kitchens and home design, and Lowe's is a great partner there. But we really do think the thing to take away from this is how to perform image analysis that Weihong will show you using deep learning, and then how to extract the features and everything you can from that to actually connect it into your business, your product portfolio, your catalog, however it may apply to you. So this could be things out in the field if you're fixing devices and your meters, or this could be retail, or this could be anything like that. So it's fully extensible.
Is this
Not yet. So that's actually our next step. I think that we're really racing, the team is racing to get this done for the Ignite demo. We do fully plan on making this a templatized solution that you can then take off the shelf and go productize. So, all right, thanks. With that, I'll kick it back to you. Thanks.
So apologies for the infrastructure issues. So early on, Sanya showed you the applications, right? Or some of the application that we showed on stage, right? At the same time, she also showed you bits that we've never shown before, including the web application. And many a times, a lot of this kind of integration project, when it comes to engineering, and we get that call, right? Yes, you know, you could either say, well, let's spend 3 to 6 months planning about it and talk about it, or just do it, right? So the application that Sanya built, the website, is really the beginning of all those demos that you saw on stage, because we needed a way to validate whether we could pull images from Pinterest, right? How do you take care of the full authentication cycle, and so on and so forth, right? That eventually accumulated into the app that you saw on stage, right? Now, and just to unpack the whole demo,
You could completely
I know someone, just before we started the session, asked whether we have a HoloLens. Unfortunately, the HoloLens is still a very controlled item, even between Sanya and I. When we work on the HoloLens project, because we're not from the team, right? We can't bring the HoloLens home, right? Much to the unhappiness of my kid, right? It's okay, right? But we do show them cool videos. Now, with the HoloLens, if some of you have experienced the HoloLens at some of the stores or some of the sessions, one of the things you realize that once you wear it, whatever that runs in the HoloLens is really a universal app. Meaning if you use Visual Studio to develop, right, and you have your target solution, you'll never be targeting a .NET Framework 4.5.2 or 4.5.1. You will target a universal app. Now, that seems a really trivial thing, but when we first started doing the integration, it really introduces a lot of challenges, right? Because one of the things when you start developing an application, a very common thing that us as developers will do is you will start importing NuGet packages, right? Now, you can't import, not all NuGet packages will work with a universal app, right? And therefore, including some of the things when we needed to connect, right? Remember, every time you put on the HoloLens on stage, Sanya and Peter glance at the kitchen, right? Glance at the cabinet, the faucet, and so on and so forth, right? We have to figure out a way to get the HoloLens, which is already connected wirelessly, to send data to the cloud, right? Essentially, look at it, that's what telemetry is all about, right? When you build a website, you know how to send data, right? Similarly, HoloLens is just like your website in codes, right? Please do not tweet about this statement, but it's not an official statement. But the point here is we have to figure out that once it's connected wirelessly, send data, right? Now, and earlier on I was telling you, because we cannot import a lot of the DLLs as well as the NuGet packages, it means that anytime you work with some of this like Event Hub, Stream Analytics, and stuff like that, right, you will not be able to use a lot of the .NET SDK. You work at the REST API level, which is documented, right? So that's the first challenge that we had. Now, we took a really short time to be able to, well, first get HoloLens to connect to the wireless network, get the code, the piece of code running in the universal app, which is the kitchen, right, to be able to emit data, right? We spend a lot of time saying, hey, you know, let's figure out the REST API pieces, right? And then the goal there was to get to a point where any HoloLens developer who wants to write a HoloLens application that sends data, they only need to write 2 or 3 lines of code without having to go through the pain that we went through, right? And later on, when I show you the code, you'll see that anytime the same code that we have, eventually we'll publish it onto GitHub as a sample, is the ability to say, well, all you need is to take in that CS library. We've already done all the hard work of abstracting away the REST API for you. All you need, similar to what you will do if it's on the website when you use some of the analytics tool, is just to say, send telemetry data, describe the payload, and that's it, right? Which means today, if you're working on HoloLens application, or tomorrow, if you intend to work on HoloLens application, and you need to send telemetry data, right, you just need 2 or 3 lines of code once you import that set of libraries that we have, which is awesome. Now, once that is done, this goes up to Event Hub, right? And for those that are not familiar with some of the Azure capabilities, Event Hub is really one of the services in Azure that allows us to ingest data at scale, right? So imagine you could have huge number of HoloLens. In this case, for Lowe's, they have the same HoloLowe's things in several stores. Every one of them can be sending telemetry data, right? For example, on stage, you saw Sanya and Peter glancing, right? Both their HoloLenses are continuously sending data to Event Hub, which is just ingesting it just like any telemetry signal that you will get. Now that it's in, we have to consume it, right? And the way we go about consuming it is we want to ask questions like, hey, you know, for a specific area in the kitchen, right, whether it's a faucet, whether it's a cabinet knob, how long did they spend time gazing at it, right? Why do we want to do it? Because remember, later on towards the end, Jen showed you guys the analytics app that Lowe's have. In order for us to construct the heat map, we need to be able to aggregate the gaze time, how long they spend on it, right? That translates to the heat map that you saw earlier. So end-to-end, it was code that was running on HoloLens, sending data to Event Hub, stream analytics consuming from Event Hub, right? A very simple window query that says, within a 30-second window, aggregate the gaze time, and then push it out. That eventually goes into a Power BI dashboard, or application that you saw during the Ignite keynote. So that's the first part. That's actually the easy part, right? And once we got to that point, we say, hey, you know, if it's on the Ignite stage and someone goes up on stage and say, hey, you know, we solved the problem of sending telemetry data. Not that exciting, right? Well, because it's a known problem, the only hard problem was just trying to get the technical issue resolved. So we say, well, let's move on to the second part of it. There is huge amount of opportunities offered by being able to integrate analytics into HoloLens. And one of the things is, well, not only can I know what you're gazing at, right, through the info card that you saw. In fact, I was telling Sanya this story that this morning at one of the hotels at the lobby, when everyone was waiting for your colleagues to come down before you head up to Ignite. We see people doing this all the time, which is really fun, right? Now, every time they do this action and they click and say, I favorite a fridge, or I favorited a cabinet knob, that means you were interested in it, not just gazing at it, but you were favoriting it so that you can recover it later. Now, the in-store design specialist that I was telling you earlier, before this integration between HoloLens and analytics, have actually an interesting problem. He or she knows what you're looking at, and what you're gazing at, and what you favorited, but he or she has a responsibility to say, well, because you favorited this, what about other people who were looking at this? What were they interested in so that they can make good recommendation instead of sifting through thousands or tens of thousands of items in the store catalog? So you say, well, now that we have solved the telemetry problem, then the next problem that we want to solve is, well, cognitive services. One of them is not just the text and the speech, they are recommendation APIs, right? So why don't we solve the recommendation APIs as well? And therefore, anytime when Sanya or Peter click on one of the items, it gets favorited. We already figure out a way to send the signal to the back end. Let's take that, and we know the product ID because you know the knob is of this item number. Let's send that back end into our recommendation engines so that we are able to say, hey, people who viewed this, in this case, people who favorited this, are also interested in this. And then through the in-store app, which is a universal app, the in-store specialist can then push this into real time, like the island that you saw, right? So that was really this piece here, which is, well, the in-store designer app, after it gets the signal, right, pushing it to our recommendation services, and getting back a list of recommended items. And then we said, well, we have solved telemetry problem. We have solved the ability to say, how do we get recommendation to the in-store specialist, right? But these recommendations are traditional applications that all of us are used to, right? Whatever commerce website that you have been to. Let's solve a more interesting problem, right? And the problem is, today, whether you're in kitchen remodeling or whether you're into fashion, one of the interesting things is you're trying to tell your friend, this is what I like. And what usually most of the conversation, I'm not a fashion kind of person, but the conversation goes into, oh, well, I really like that white dress or white shirt, but what captures your style and your preferences? So that becomes a really deep question. But it turns out that all these years, all this innovation in deep learning, specifically in deep neural networks, has made that possible because it's able to capture your abstract style. So I said, why don't we take a lot of this technology that we already have, right? And let's use this to be able to capture your style, which is style from the Pinterest images on your board, like Sanya showed you earlier. And then being able to use this to correlate this or to be able to match this against all the items in the Lowe's catalog. And what will that get you? That will get you to a point where you can now have a good conversation where the customer comes in store, they send you the photo, and you tell them, hey, based on your style and preferences, these are really what I like, right? And of course, from a back-end perspective, there's two parts. The app itself is a universal app, and therefore, whenever you submit a photo, it invokes a web API that returns the matches, which is the 83%, which is Cornerstone, and the rest of the kitchens, right? But that is only one part. So right now, our operationalization back-end, we have not shared it externally yet, right? It's essentially a web API against a proprietary is not the right word, but against a system that we develop internally for the demo. Eventually, we will figure out a way, right, to make it operationalizable, right, so that then you can consume it. Now, today, there's a lot of options for operationalization. One way of operationalizing it is to say, well, why don't we wrap, after you train the DNN, right, and you get the last few layers, which I'll show you in a while, right, then let's abstract these last 3 layers, one or two layers, which are the featureizers, and encode this, and you could put it into a database, it could be put into a web API code that you write, right? At the end of the day, from an application perspective, there is an API that they invoke where you'll give it an image and you'll return a list of images, right? It's all this DNN part is all abstracted away from the application, right? And therefore, then we have a lot of flexibility in changing what this operationalization backend is, right? Now, the next part is how did we train our DNN, right? Today, from a DNN perspective, there's a few common topologies, right? And early on, you'll see some of the talks, or even at the keynote you saw, we talked about some of those, right? You have training and AlexNet, right, on ImageNet. ImageNet is a huge collection of images, right? And then using that as a way to do featureization, right? And of course, over the years, and we'll show you a slide later on, we have progressed from AlexNet all the way to Google's LayerNet, and more recently, which is that 152 layers CNN that we had, which is ResNet, right? And therefore, today, whether it's Microsoft or many of the other companies, we provide tools. And from a Microsoft perspective, this DNN backend training is essentially, we use CNTK for doing that training, right? And finally, we extracted the last 2 layers. Those last 2 layers is what we put into this operationalization layer, right? Now, so let's drill down into each one of this. Let's take a look at what happens here before we get into the DNN piece. Now, under the hood, remember that few lines of code that I was telling you? Right now, if you take any of the HoloLens sample, today you don't need the HoloLens to try developing for HoloLens. All you need is Unity and download a lot of the samples that you get off the HoloLens sample site, right? Every time you look at any of this sample HoloLens code, you would be able to find a part of the code, right, that says update. And what this is simply saying is that as the HoloLens is receiving signal, right, they have what is called as a raycast object, meaning when the HoloLens, what are you looking at? So there's a raycast, it returns. The HoloLens is aware that you're looking at the object, right? And this is always in a method called update in all the HoloLens samples that you will see, right? And therefore, all we did in order to do the integration is simply to say, well, this is a code that's already in the sample. Let's just add this 2 lines. In this case, this was a debug line so that we know what is happening. But the next line is really a library that we created, which I'll show you the code in a while, that says send data. In this case, I say this refers to a gaze, and what is the name of the object. Now, if you translate that to the Lowe's demo, that simply means if you're looking at a cabinet knob, this game object.name would be the cabinet knob, or the ID of the cabinet knob, right? And this is how we are sending data up to Event Hub, right? And finally to consumed by Stream Analytics. So let's take a look at the code on how this looks like. What is inside Cortana Intelligence Analytics? This is essentially a wrapper that we wrote. And if I go from top to bottom, right, that figures out how to authenticate with the Event Hub service, right? And it turns out that it's straightforward, but not straightforward because you have to dive through tons of materials on the web. But here is simply trying to create the auth token and finally getting to a point, if I get down to send data. Send data simply construct a payload, which is the event data. It creates the token. In this case, I'm connecting against this specific service bus, right? I'm passing in a key. Now, I will give you half of the key so that yesterday after the demo, everyone was hitting our external website and we get quite a lot of requests. Please don't connect to this service bus, right? And the hub name. In this case, the event hub name is called HoloLens 2. And finally, now that we have the payload and we've created the auth token, it becomes really simple, right? We serialize the payload, and all we need is just a REST API request using a standard HTTP client, where we post it in an asynchronous manner, the content, right? And therefore, in the HoloLens piece of the code, which is inside usually a file called cursor manager, we will simply just say send data, and all the underlying magic underneath gets abstracted away, right? And the goal, as I was telling you, is we want to get to a point where we make it easier for all HoloLens developers developing HoloLens applications to be able to have telemetry data just out of the box, right? Which is super powerful. Now, the next thing in the slide that you saw earlier was we want to be able to move one step further and being able to get recommendations. So you say, well, how do we get recommendations? Well, you could build a recommendation model using transactional data from the company that you work for. In this case, what are the things that people buy, right? Or you could build it from various kinds of web interaction. But the point here is you can build a recommendation model, and Microsoft provides you with both the API to train a recommendation model, as well as the API for you to operationalize the recommendation model. And all it takes is after someone does this favoriting action, right, we invoke a piece of code that says get recommendation. Group style name, in this case, refer again to the same thing that you selected, right? And once this comes back, right, we just need to check whether R is not null, right? And we simply add this to the list of recommendation item that shows up in the application that the store person was seeing and which Sanya showed you earlier, right? Now, then the question is, well, how do you go about building a recommendation model, right? The way to go about doing it is, in the past, you would have gone to the data market and you do a recommendations, and you see the prices, and you can actually get the sample application here. Today, with cognitive services, which is recommendation, you'll click on this recommendations, and this will bring you to a page that says, hey, you know, how do you get started? How do you use the API? And you'll get the same piece of sample code, which I'll show you in a while. Once this is done, in order for you to create the Cognitive Services API that provide you with recommendation, you will go to the Azure portal, and in this case, you will say, hey, you know, let me choose to create Cognitive Services API, create, give it a name, say HoloLens, give it a subscription, choose the API type. In this case, I will choose the API type, which is recommendation. Now, specify a bunch of stuff like your pricing tier. Free, which is great, right? And choose a resource group. For example, I could say, well, I want to use a resource group called demos. Data test drive, not is a good idea. And I'll click create. Now, once you create this, you'll get several things. You'll get the API URL, which you can invoke in your code, and you will get a key that will be used to do basic authentication, right? Now, once this is done, then it becomes really easy because we already figured a way for the HoloLens to communicate with the cloud services, right? And therefore, we will then, within the code, let me just show you the recommendation code. Yes. I will simply say, well, now I received the data, do that recommendation, it's the same piece of code that you saw earlier, and that becomes the little thing that lights up in the application that the in-store specialist will see. Super powerful. Now, what is that sample app? If you download the recommendation sample app, this will essentially be code that you can easily reuse. This has a part that allows you to train and create the model. And you will have a part that says get recommendation. Now, we took the sample code and we modified from this sample code, just that now we are using a Lowe's recommendation model, right, through Cognitive Services API, and it just works, right? So that's the second piece, which is how we created the recommendation. So if we get back to the slide, let's quickly move on to the next part of this. Now, this slide, you have seen it at the keynote, I'm not going to repeat, but the point here is today Microsoft has done huge amount of innovation in the deep learning space, and we have one of the deep, right, neural nets called ResNet, right? And to put that into perspective, right, we have data coming from ImageNet. ImageNet is a huge corpus of images that represent a wide variety of categories. Right? There are millions of images, and therefore, when you train an AlexNet, which simply describes a topology on top of ImageNet data, right, you get multiple layers. And usually the last few layers, which I'll show you in a moment, right, are the layers that are called featureizers. Those are the layers that you want because you want to use the featureizers, right, to featureize images coming from Lowe's, and also to featureize the new images that are submitted to you, right, via a Pinterest board or a Bing search. So in this case, in this phase one, it's just a standard training of an ImageNet or AlexNet, right? You have different deep learning toolkits available. You could use CNTK. Internally, we have our own toolkits as well, all originated from similar roots, Microsoft Research. And you could have different network topology. Now, specifically for the Lowe's demo, we're using AlexNet. In fact, some of our deep learning guys has already started moving it to ResNet, right? And we've been seeing quite good performance in that sense. Now, and once you have done with it, you really drop all the layers of the AlexNet except the last 1 or 2 layers, because that's where the most effective featureizers are. Once you're done with training, it's a one-time thing unless ImageNet evolve. Then you really want to get to a point where you want to get the last few layers. So I added this slide just to show you an example where you have an image. And what we meant by layers is that this is used as input. Now, in a convolution network, the last few layers will show you something like this. So layer 1 gives you different kinds of color gradients. You will see that layer 2, you start surfacing some contours, some shapes, but it's still very abstract. And as you move from layer 2 to 3, you'll see that they start grouping things together, so that it's more higher level concepts. By the time you hit to one of the lower layers, it is already some object. In this case, we're using that to denote your style and preferences, right? So I added this slide just to show you what is inside the AlexNet. Now, and you'll see this diagram very often in a lot of deep learning kind of talk. Now that we have this, Lowe's gave us almost quite a huge set of images from their product catalog, right? Remember, we already had the featureizers. So what we did was we took all their images and we ran all their images through the featureizers that we trained earlier to give us a point where we are able to say for each of the Lowe's image in their Lowe's catalog, a hash feature vector. Now, this feature vector, as I was telling you, you have different operationalization options. For this specific demo, we are storing this hash vector in a database. You could store it in a NoSQL store like DocumentDB. You could store it anywhere. The point is you need to store it in a store that allows you to do efficient query processing, because later on you're going to do a lookup. Now this is done. When you have a new image, this could be a Pinterest image, this could be a Bing search image, we run it through the same featureizer. We get a hash feature vector. We compare this against all the feature vectors from the Lowe's catalog. Now, and each one of them is going to give me a score. And of course, there's different kinds of distance measure that you can use, right? You could use Euclidean distance, which is really simple, or you could use a weighted Euclidean distance, and a bunch of different kind of distance measure that you can use. And the trick is really to find the right one, right? In order to get the effective results, right? Now, once this is done, we rank it based on the similarity, right? What gets shown on stage was the top top 5 of them, right? And that's it. It's as simple as that. So let's get back to Nino.
Thanks, Rehan.
Thank you.
It was really good. Am I on? Okay.
You can use mine. Yeah. Yes. Just press down. Yes. Sanya can take that question.
Can you repeat the question for everyone?
Okay, so the question is, we send an image, right, a new image to our back end. What is the size of the image? Yeah, Sanya can take that.
Can we turn Senya's mic on, guys, in the back, please? Or Senya?
So we don't send images up from the HoloLens. We just send model numbers of the products because everything is pushed to the HoloLens, so we know the correspondence on the back end. The image parts are just coming from Bing Image Search and Pinterest, and they are fed into HoloLens. They're actually fed into the InStyle app, and then from there, run through the DNN, gotten the respective top selection from the DNN, and only the known models, so the lowest products, are pushed into the HoloLens.
So remember, there's 2 parts. There is the telemetry data that we are sending from the HoloLens. Those are just pure numbers, right? And there's a second part, which is the application. The application has nothing to do with HoloLens, right? It right now runs in a Surface app. You'll run on a PC with Windows 10. Right? That application, when you upload, say, a Bing image, right, or a Pinterest image, we will send the image as it is. We do not crop it in any way unless you're only interested in a specific area of interest. When this goes to the back end, the featurizer will usually change it to either 28 by 28, right, or 56 by 56, or sometimes, depending on the back end that we have, you could have 256 by 256, right? Standard usually, in order to balance between the complexity of computation, right, is usually 28 by 28, right? Yeah. Yeah, back to you.
It's always interesting to me, the more and more we implement in practice convolutional neural networks, the parallelisms I draw with teaching my children what is in their book they're reading and pointing out the things in the imagery, and you're like, we're replicating that with a data model and a computational model. So it's cool stuff. I think to your point earlier, sir, I think you caught me on the side, that last couple layers, the feature engineering you'd perform, that's where you'd specify, like, as opposed to doing home kitchen design, I'd like to look at a parking lot of supplies and visually understand what that means in terms of inventory. So you can sort of see how it trains on itself. And one more thing too is as we think a lot about everybody, actually all of our platform partners provide capabilities like this. A lot of these frameworks are open source, but at the end of the day, when you pick a platform, you want to pick someone who has a lot of experience and maybe even a catalog of images, like maybe an index, like a search engine index, because at the end of the day, the accuracy of which you perform this is really makes the difference between it working or not. So little plug for the extended platform. All right, so one of the other things too we got a lot of feedback on is, and I think we covered this in the demo, in Jen's demo, was shifting over to the analyst. So what does this look like? How do you hook this up? So not only just are you introducing personalization into your application, but how do folks at your company, how can they leverage these analytics? So just to kind of give you some inspiration here, this is what we think a dashboard would look like if you were connecting to curated applications across your customer base. So in this case, here...
I have it running, so you can get
Is it running?
Yeah.
Okay. After we've maybe analyzed, 1 million Pinterest boards, now we're able to really understand what are all the things our customers love, basically broken down by region and broken down by time, right? So why this, Lowe's especially really resonated to this, because you're really not waiting for trends and you're not waiting for new things in the market to happen and for you to buy a really expensive research report for your business, but you're able to almost in real time, as your customers share their interests with you, understand what their preferences are. This, of course, is really valuable to product planning. Let's go to the next one. So the other thing, as you saw too, is we didn't cover this, I think, in the detail, but it's worth pointing out. Understanding and capturing that conversation, all of the DNN stuff aside, but using our Bing Speech API and our Text Analytics API really resonated strongly in this demo around You know, and it was funny, I love we would make jokes, the HoloLens is like this phenomenally new mouse. You know, it captures all this additional signal now that you couldn't capture in a 2D way. But in a serious way, applying that to, and then overlaying that with text analytics, you can now actually understand how your customers are experiencing your products on the showroom floor, for example. And that doesn't go through 3 to 4 people you know, aggregating that data, but you're capturing it right then. And this is simply us using our Bing speech API, and I'll explain that, and then overlaying that, and then running it through the text analytics to get sentiment, for example. Okay, so let's go back to the deck. Thanks, man. Perfect. All right, so this kind of, you know, I think if there's one slide that's sort of the cheat sheet, this would be it. So, you know, in this case, we have our customer opinion. This all comes back to capturing customer opinions, the entire point of this. So we have Pinterest images or from other curated applications. And then, of course, we have WAV files. We simply record, you know, remember in Jen's demo, she said, do you mind if we capture verbal comments, right? Of course, you know, do you want to do that in a cool way? And it's anonymized data, it's aggregate data, but we essentially upload WAV files to the cloud. These go into something like Data Lake, so I'll start to plug product names here, but you could use whatever you want. And then from here, we basically run a data prep service, which takes those WAV files, converts them to text, which is an API available today. And then once they're in text, then we send them over to the text analytics service, and then that, of course, does things like extracts entities, so nouns and verbs and sentiment and scoring and ranking. We get that JSON payload back. And we could probably throw that back up in our data lake, for example. And then Weihong covered the DNN service in detail. And of course, as we talked about, that pulls from the product catalog for those last couple features. And then you can imagine that once this stuff comes out of your data lake, or that could be even a relational DB if that works for you, that goes to, think of it like that scoring, ranking, analytics aggregates. This could be your company's data warehouse or a set of databases that, you know, maybe you guys do cube analysis off of. And then over here we have Transaction DB, which, as Weihong pointed out, powers the recommendation engine. We have the product catalog, and then the ranking and matching. So this is a key capability of how do you know what to show them from your product catalog, right? So you have to really think through that. And then, of course, then to get to the dashboard that Sonia built and we showed is you can just simply do regular analytics data binding at that point. So the whole thing lights up. So, you know, we wanted to show, yeah, this is visionary and really cool, but at the same time, I think if you implement these design patterns, here's an easy way to plug it into your analytics infrastructure so you can push the stuff to the end users and then they can sort of slice and dice it how they want. So I think that completes it. I think that's the whole deal. You know, again, we just wanted to kind of unpack the demo for you guys, show you a little bit of thinking that went into it. A lot of these capabilities, actually, I think all of these capabilities are commercially available today. So I think the visionary part was just sort of putting it all together. And we'd love to hear your feedback either today or offline on, you know, how you'd like to apply this to your specific business as well. And if there's any questions, I think that concludes the session. So
Thank you, everyone.
yeah.